Welcome back. I was thinking I need to spend a whole lesson on radian measure. Then I realized there are only two standard formulae, arc length and area of a sector. And of course, using those two you can always get area of a segment as well. That is no problem. So the problem I have is, do I need to do that? No. But I need to introduce you to radians because they're very important. So if you want to know, look, obviously, if you have a circle, if you have a center like that and a radius r, if I have an arc AB, the length of the arc AB is also r, then this angle is called 1 radian. This is how your teachers and I for 50 years have defined the radian. Is there another way of looking at radian? I put the title earlier because I thought I would introduce you to that. For example, suppose you take up a circle, let's say the unit circle, okay? Suppose I have 1. The radius is 1. I am now moving along that. In other words, I am moving now along the circle through 1 unit. Maybe this radius is 1 kilometer or 100 meters. So you got a circular path, a circular track, and then I am looking at how you are moving. Then you see this, what does this one represent actually? This represents something like, if you are walking along the track and the distance between me and you is always 1, then even let's say distance between me and you is 10, I am 20 meters away on a circular track. I am at the center. So between me and you there's 20. When you move 20 meters along the circumference, my eye would move like that. In other words, how much I turn depends upon the distance you have traveled along that circumference. That is how you look at radian. Radian is considered as, or is looked upon as, it's a measure of the distance measured, distance moved along the circumference. Meaning, if I move through a distance L along the circumference, and because of that the angle at the center is theta, then the length of the distance moved along the circumference divided by the angle is the ratio r. In other words, if you see, suppose I draw concentric circles, this could be L1, R1, this is, let's say, R2, and this is L2. L1 over R1 is also theta, L2 over R2. In other words, for a given angle theta, with in radians, the distance moved along the circumference is always the same, divided, it bears the same ratio with the radius of the circle for that particular circumference. Yeah? So, that's how you get L equal to R theta. So, this is something we need, so I just put it there. So, I know I haven't mentioned anything about this, I'll compute in a minute. So, I can say arc length equals R theta, which you have learned theta must be in radians, otherwise it is 3 over 360 times 2 pi r. And similarly, area of sector is pi r squared. Sorry, a half r squared theta. And you have got umpteen questions in any textbook on this about the pendulum or the clock, and the circular field or the sweeping of a radar screen, whatever you want. Basically, you're dealing with a diagram. with arc lengths. So I'm not much interested in that. I'm not going to do it. But I need something else. You also know, okay, before I proceed further with what I want to do, I want to introduce you to this particular article. You know, how much is the central angle of a circle? Can you tell me? So, 360 degrees. Before I can say there will be 10 people. 360, 360, 360, yes. How do you know it is 360? Why is it not 480? Our teacher told us it's 360. Because the circle, someone is clever. There's a clever dude there. Or there's a lady, she says, oh sir, you know, you divide the circle into 360 equal parts. Then you see it's easy to work with, so each part that's 100 degrees, so it's 360 degrees. Why couldn't you divide the circle into 400 equal parts? In fact, you know, in 1938, they decided to divide the circle into 100 equal parts because that was the time when they wanted to bring in the decimal system. It started in France. They used to call it as grade. Not 100, 400. Right angle was 100 grades. But then it fell flat because it was more cumbersome. Then, where did this concept 360 come from? I learned from my teacher. You learned from me. My teacher learned from his teacher. His teacher learned from his teacher. His teacher learned from his teacher. If you go backwards, it goes back to the Babylonians in 3500 BC when they used a circle as 360 degrees because they needed it for their areas and surveys and astronomy. But why 360 degrees? According to historians, I don't know how far it's true. According to historians, there were two reasons. One was the Babylonians, like, you know, we have today a decimal system. You need 10, 100,000. Or people who do IT or who do a bit of computer studies would know the binary system. 1, 2, 4, 8, 16, 32. In fact, 1 is 2, 1, 0 is 4, 1, 0, 0 is 6, 1, 0, 0, 0. 8, 1, 0, 0, 0 is 16, 10 power, similarly and so on and so on. It's the binary system which is used in the computers because there are only two numbers 0 and 1. Okay? 3 is actually 1, 1. Do you know that? Because it is 1, 0 plus 1. 3 is 1, 1. Anyway, so they used a base 60 for their numbers. Why did they choose 60? Because 60 was those days, they only knew positive numbers and they knew how to divide. So they knew 60 as a number of divisors. 2, 1 is always there. 2, 3, 4, 5, 6, 10, 12, 15, 20, 30. So it had a big, huge number of divisors. Yeah? So they had a system of counting in base 60. So that was one reason why they chose 360, because they realized also, because you know they were observing the sky, the constellations. They realized that there were 12 constellations, right? And then they repeated themselves once every year. You know, a constellation would take 365 days to go once around the earth. You know, actually there is relative motion. The constellation is not moving. It is the earth which is moving, but they thought the earth was stationary and the constellations moved. Yeah? So, but they knew roughly their day and night. Somehow they calculated 365 days. But because 365 was not convenient, they said, let's leave the 5 out because in a whole year, 5 days doesn't matter. So they chose 360. So they said a circle is 360 degrees. Brilliant. That's how it was just if they had chosen 720, today math teachers like me would have taught you 720. Whereas the radian doesn't depend upon that. The radian is always whatever the circle you draw, 1 radian is always, it's not, it got nothing to do with how much you turn, it is the ratio of the arc length divided by the radius. Arc length divided by radius gives you so many radians. A unit circle, an arc length of 1 divided by radius 1 is 1 radian. Arc length of 2 divided by radius 2 is still 1 radian. Arc length of 1000 divided by 1000 is still 1 radian. Yeah, so that's how they brought it. If you want to read more about it and understand, there is a website called betterlinkexplained.com. You can look at this and write down. And once you go to that, search for Intuitive Guide to Angles, Degrees and Radians and read through the article. It discusses what are all the things I discussed, and in much more detail and in a more interesting way. My way was boring. Yeah. Okay. This formula, you know, so I'm not much interested in that. As you know, if you take your calculator, find in radians, not in degrees, sine theta, and then divide it by theta, you get almost 1. For example, sine of 0.1 is roughly 0.1, sine of 0.01 is roughly 0.01, sine of 0.00001, 6 zeros and 1, if you find in radians, not in degrees, change the mode of your calculator radians, you get 0.6 zeros and 1 approximately. So in other words, for all small angles, so for small values of theta, sine theta is approximately theta. Okay? I need to do a couple of questions on this because this is a common question in your papers. That's why I'm taking that. And then, what about cos theta? What is the formula for cos theta? Using double angles is cos 2a is 1 minus 2 sine squared a. Isn't it? What is the formula for cos 2 theta? Cos theta is approximately 1 minus half theta squared. Now, where am I getting this from? I don't know where I'm getting that from. Can somebody help me how to arrive at cos theta is approximately 1 minus half theta squared? What double angle formula for cos theta? Cos theta equal to 1 minus 2 sine squared theta, correct? 2 sine squared theta over 2. Yeah. Isn't that correct? Because this formula your teacher has given. And you're wondering, where did he get that formula from? Did you find out? Of course, your teacher will have told you, but you have forgotten perhaps. Okay? Now, if sine theta is theta, so do you agree sine half theta is approximately half theta? Isn't it? If sine theta is theta, half theta is still smaller. So sine half theta is half theta. So it is 1 minus 2 times half theta squared. Expand it. 1 minus 2 times theta squared over 4, which is 1 minus theta squared over 2. These are called small approximations. So, if you have been given in the exam, theta is small, show that. Depending upon the question, you ignore theta cube, you ignore theta power 4, sin theta is theta, cos theta is approximately 1 minus half theta squared. Let me see if I can get some questions on this. I'm not too sure. I should be able to get some questions on this. No. I should be able to get some questions. Let me see if I can get some questions, because I can't make up questions in this because I will go wrong. It's not always easy to make questions on this. For example, find approximation. So this is something you should know, and you want to make a note of that, want to read it just out of interest. It's pretty interesting. You can do that. I'm just doing some questions on small approximation. So for example, find an approximation if theta is small. If theta is small, find for example, theta sine theta over 1 minus cos 2 theta. If theta is small. Okay. Theta is small, sine theta is theta over 1 minus, what is cos theta? 1 minus half theta squared. So what is cos 2 theta? 1 minus half 2 theta squared, isn't it? So 1 minus half of 2 theta squared. So what does it become? Theta squared over a half times 4 theta squared, which is theta squared over 2 theta squared, approximately half. Yeah? Or something like, remember sine theta is theta, cos theta is 1 minus half theta squared. I'll just put that in my handout, but I'm putting the formula for arc length. This only for those who want to make their own notes. Is r theta, sector area is half r squared theta, and then 1 radian equals angle at center by an arc of radius r, an arc of length r on a circle, in a circle of radius r. You don't have to know that, it's better you know the definition of or the measure, radian measure. And you see, obviously, 2 pi radians equals 360 degrees. Remember, pi is still and always 3.142, and so on. It hasn't changed. It's now going to change. Pi is not 180. Many students say pi is 180. Pi is not 180. Pi is still 3.142. When you convert pi radians into degrees, then you get 180. So in other words, theta degrees equal to convert degrees to radians. To convert degrees to radians. Angle times pi over 180. Whatever is angle, multiply by pi, divide by 180. Okay? Then, I have done so many questions and trig equations, right? But for example, 30 degrees is 30 times pi over 180, which is pi over 6. 45 is pi over 4. 60 is pi over 3. 90 is pi over 2. 120 is 2 pi by 3. 135. 135 is 3 pi by 4. 150 is 5 pi by 6. And 180 is pi. In other words, radians. When you convert degrees to radians, that's what you do. If you were to do it the other way, degrees will be angle in radians times 180 divided by pi. Okay, this is what we expect. From now on, when we start calculus, it's always from now on till, unless the question says degree somewhere, we forget degrees. Degrees are restricted to trigonometry. Beyond trigonometry, no degrees. It's all radians, 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 radians. So if you're differentiating cos x when you're solving, for heaven's sake, don't say x equal to 30. You'll be marked wrong. You must say x equal to pi over 6. When you're doing Newton-Raphson's method and doing iterations, when you're solving a cos x, you don't use cos 30 then. It's all radians. Anyway, differential equations, radians. Everywhere it is radians. Degrees start and stop at trigonometry. Or maybe later on when we do vectors, you might use it. But generally, otherwise, the moment you're differentiating, the moment you're integrating, we talk only of radians, not of degrees. That's a common error students do. Do not use degrees when you're when you're differentiating or integrating. Why? We will know later when I do differentiation. I've done a lot of questions. I would suggest, for example, if you have seen me do a question 0 to 360 degrees, convert it to 0 to giving your answer in the range 0 to 2 pi, the exam will say. That means you're indirectly told you have to work in radians. So change your, please don't use this formula, angle times pi, already can do it, that's long, but change your calculator to radians, straight away write the answer as 3.24 or 1.78 or 2.92, whatever it is. Alright? But if it is a standard angle, that means if your angle is 30, 45, 60 or multiples of that. For example, suppose you have 210. 210 is 7 times 30. So 7 pi by 6. So if it is a standard angle, we expect you to give the answer in terms of pi. If it is not a standard angle, you can give to 3SF as you always do. Okay? I just want to bring that point out, otherwise I don't want to spend more time going over again the same boring questions in trigonometry. So I'll leave it to you. You can take each one of the trigonometry questions which I have done, which are in degrees, and convert everything, including the R formula, alpha. So how do you get a hint? Sir, when will I use degrees? When will I use radians? If the range says 0 to pi, minus pi to pi, 0 to 2 pi, you know it is radians. Otherwise, 0 to 360, minus 180 to 180, you know it is degrees. So they may not mention radians, but they do mention radians most of the time. In which case, if they don't mention, go by the domain given. 0 to pi, 0 to 2 pi, minus pi to pi. The moment you see pi, you know it is radians. Change your calculator to radian mode and do it, okay? Then your PV, everything will be in radians. I don't want to, I'll just, if you want to, write down, for example, what is the formula for sin x? To solve sin x equal to k, x equal to 360n plus PV, 360n plus SV. Now, 2 pi n plus PV, 2 pi n plus SV, where SV equal to pi minus PV. But please don't do pi minus 30 degrees, pi minus 72 degrees. No. Convert 72 degrees or 30 degrees into radians and then do pi minus that. You can't subtract a radian and a degree. Either everything is radians or everything is degrees. So I'll leave you to figure out those things because they are quite straightforward. I don't want to spend, I don't want to unnecessarily take your time trying to go through the same trigonometry question. Halfway through you'll get bored. Okay? So I'll see you next time. I want to talk about an important result and then go on to concept of a derivative. Okay? See you. Bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.